will explore how tech giants like Instagram, Netflix, and Amazon efficiently manage enormous amount of data, and these companies handle large-scale systems where performance is critical. So Netflix is a prime example of how data partitioning can help deliver fast and reliable video streaming. By partitioning video data across multiple servers, Netflix ensures that you can stream content quickly and reliably. So replication involves creating copies of data across multiple servers. This is essential for maintaining the reliability of your system. For example, imagine that one server is being responsible for handling user data in the 19 to 35 age group. So if that age groups contain significantly more number of users than the others, the server will become overloaded. Everyone, welcome to Preptrain YouTube channel. I am Sahil Kumar, and if you are new here, Preptrain community is dedicated to helping students and freshers level up their engineering skills. At Preptrain, we focus on making backend development easy to understand with practical insights, real-world example, and step-by-step guidance. Whether you are just starting out or looking to sharpen your skills, you are in the right place. Now, let me ask you a quick question. Have you ever wondered how platforms like Instagram, Netflix, or Amazon basically handles billions of users and transactions effortlessly? Well, the secret lies in data partitioning and many other concepts, but today we are diving into this fascinating topic to uncover why and how. Data partitioning might sound technical, but don't worry, I am here to break it down in a way that is easy to understand and, more importantly, relevant to your career in tech. Whether you are an aspiring backend engineer or just curious about how this system works, this video is for you. Before we jump into the details, make sure that you hit the subscribe button and turn on notifications so that you never miss out any of our upcoming videos. Trust me, you don't want to miss out the valuable content that we have got planned for you. Also, if you are looking for more resources, job opportunities, internship, or just want to connect with other developers, join our Preptrain Telegram community. It's a great place to stay updated and grow your network. Alright, let me bring my deck and then we will dive deeper into the details of data partitioning. Stay tuned. Alright, let's start by imagining your Instagram feed. Have you ever wondered how it loads so quickly even though millions of users are active simultaneously? Behind this seamless experience lies the concept of data partitioning. Data partitioning is essential for making systems scalable and high performing, and without it, handling millions or even billions of users would be impossible. You see, as a system grow, the amount of data that basically a platform needs to handle increases exponentially. To deal with this efficiently, systems must be designed to scale without compromising on the performance, and that is where data partitioning comes in. So today we will explore how tech giants like Instagram, Netflix, and Amazon efficiently manage enormous amount of data, and these companies handle large-scale systems where performance is critical. And the key to this is efficiently lying in how they distribute and manage their data. Think about it, how do they handle such massive data so effortlessly? So throughout this video, we will dive into the mechanics behind data partitioning, exploring how it helps systems stay fast and reliable, and even under high load. So by the end of this video, you will be having a clear answer to all of these questions. Let's now break down the concept of data partitioning and see how it actually works. What exactly is data partitioning? Imagine having a huge library of books, billions of them or millions of them. Instead of piling them all into one room, you split them into smaller connections and place them in different rooms. This makes it easier to find the book you need and no single room gets overcrowded. In data partitioning, we do similar with large dataset. These dataset, instead of being stored in one massive database, they are split into smaller and more manageable pieces called partitions. These pieces are then distributed across multiple servers. Now, why is this important? First, splitting data into smaller chunks allows each server to access and process its proportion of data much faster. This makes system more responsive and improve overall performance. Secondly, partitioning enables scalability. As the volume of data grows, we can simply add more server to handle the increased load without affecting the performance of the system. And it also improves reliability. So if one server goes down, it doesn't bring in the whole system to a halt as the data is spread across the multiple servers. In summary, partitioning helps in three major areas: performance, scalability, and reliability. It's a crucial technique that ensures that system basically remain efficient even as the volume of data that they handle increase exponentially. Let's try to understand this further in next slide with a real world example. Alright, let's simplify this with a real world example: pizza delivery. Think of a city basically divided into delivery zones. Now, each of these delivery zones has a separate driver. And imagine if there is only one driver responsible for the entire city. That driver would be basically overwhelmed and the delivery would take much more longer. But by dividing the city into smaller zones, we ensure that each driver handles a specific part of the city and deliveries can be made more quickly and efficiently. This is actually how data partitioning works. So each delivery zone basically represents a data partition and each driver represents a server. By dividing responsibilities, deliveries are faster and more efficient, just like system performance improved with proper data partitioning. Remember, the goal is to make sure that every zone or partition operates efficiently without overloading any driver or server. Just like we want to avoid, one delivery person to being overloaded with too many deliveries, we want to ensure that no server is overwhelmed with too much data. Efficient distribution of tasks leads to faster results and better overall system performance. Alright, now that we have discussed this example in detail, let's talk about different methods for data partitioning. Alright, so there are mainly two primary methods of data partitioning. One is range based and one is hash based. Let's dive into both and see how they work. So in range based partitioning, data is basically divided into specific ranges. For example, you could split the user data into age groups, let's say 0 to 18, 19 to 35, 36 to 60. It's simple and predictable. If you know your data is mostly evenly distributed across these age groups, this method works very well. However, there is a challenge. If one group, let's say the 19 to 35 age range, has significantly more data than the others, you could end up with some servers being overloaded while others remain underutilized. This is called skew and it can hurt performance. On the other hand, hash-based partitioning uses a mathematical hash function to distribute data evenly across servers. So each piece of data, let's say a user information, is passed through this function and it then get assigned to one of the server based on the result. This ensures an even distribution of data, helping to avoid skew issues. The challenge, however, is that it can be more complex to implement, especially when it comes to rebalancing data if you need to add more servers to the system. This requires recalculating where each piece of data should go, which can be tricky to manage. Both methods have their benefits and challenges. Range based partitioning is simple and predictable but prone to skew, and hash based partitioning is great for even distribution, but it's a bit more complex to manage and especially when scaling the system. Alright, let's discuss some of the challenges in data partitioning in the next slide. While data partitioning is a powerful tool for managing large-scale systems, it comes with its own set of challenges. Let's take a closer look at these three key issues that developers and engineers face when they are working with partition data. The first challenge is skew. So this occurs when data or traffic is not evenly distributed across partition. For example, imagine that one server is being responsible for handling user data in the 19 to 35 age group. So if that age groups contain significantly more number of users than the others, the server will become overloaded and this can result in slow responses and system bottleneck. To mitigate the skew, it's crucial to use dynamic strategies to balance the load across server. However, dealing with this imbalance can be tricky and it requires careful monitoring and adjustment. Next, we have rebalancing. So as your system grows, you may need to add more servers to accommodate the increased data. This means you will have to redistribute the data to ensure that a balanced load is going on across all the server. Rebalancing is not just a simple task, it can be disruptive to the system and might temporarily basically affect the performance. However, without proper rebalancing, some server could become overloaded while other remain underutilized, which could negatively impact the system performance and efficiency. Finally, there is the issue of consistency. So in distributed system, keeping data synchronized and up to date across all the server is critical. So if data is partitioned and replicated across multiple server, there is always the risk of inconsistency, especially if one server fails or lag behind in updating. So inconsistent data can cause errors and disruption in the user experience. So it's important to have a mechanism in place that ensures that all servers are updated in real time. In summary, while partition improves the performance, scalability, and reliability, it's not without its hurdle. So now that we have understand these challenges, let's take a closer look at how replication and rebalancing play key roles in addressing these issues. To address the challenges that we just discussed, there are two critical concepts that come into play: replication and rebalancing. First, let's talk about replication. So replication involves creating copies of data across multiple servers. This is essential for maintaining the reliability of your system. So if one server basically fails, its replica can step in and ensure that the system continues to function without any downtime or data loss. Replication is also crucial for improving read performance. So with multiple copies of data, request can be distributed to different servers, reducing the load on any one server. This helps maintain fast response time even during peak traffic. Now let's dive into rebalancing. So as your system scales and more servers are added, it's important to distribute data across new server to maintain a balanced load. So if you don't rebalance the data, some server might become overworked while others sit idle. This could lead to performance degradation, with certain part of system being slower than the other. Rebalancing basically ensures that all the servers are operating efficiently and equally, which is essential for maintaining system performance as the system grows. Together, replication and rebalancing are crucial for handling the growth of data in a distributed system. They basically address the issue of data availability, fault tolerance, and load balancing. Now, let's move on to see how these concepts are applied in real world. Alright, now that we understand the importance of data partitioning and replication and rebalancing, let's look at how these concepts are applied in the real world by some of the largest tech companies. So Netflix is a prime example of how data partitioning can help deliver fast and reliable video streaming. By partitioning video data across multiple servers, Netflix ensures that you can stream content quickly and reliably. Even during peak times when millions of people are watching at once, the partition data allows Netflix to distribute the workload efficiently, ensuring that minimal buffering and fast loading time. Instagram is another example. With billions of user profile and feed, Instagram needs to manage an immense amount of data. Partitioning is the key to delivering a seamless user experience, enabling Instagram to quickly load personalized content, whether it's your feed, messages, or stories. Thanks to data partitioning, Instagram can scale effectively even with the large number of concurrent users and the growing volume of media content. And then there is Amazon, which processes millions of transactions every second. Data partitioning helps Amazon handle this massive load, ensuring that each transaction is processed quickly and accurately. And by partitioning data across multiple servers, Amazon can distribute its operation and avoid overloading any one server even when there is a surge in traffic, such as during Prime Day or Black Friday sale. So these companies all rely heavily on data partitioning to handle vast amount of data efficiently and deliver fast, reliable services. Now that we have seen these real world application, let's wrap things up with the key takeaways. To wrap up, let's revisit the key takeaways from today's video. Data partitioning is basically crucial for enabling large scale system to efficiently manage massive amount of data. By splitting data into smaller, more manageable chunks, system can handle growth without sacrificing performance. We explored two main methods of partitioning: range based partitioning, which help is simple and predictable, and hash based partitioning, which ensures a balanced data distribution. Each method had its strengths and challenges, but both are essential for backend engineers when designing a scalable system. Finally, we saw how data partitioning basically plays a vital role in scalability and reliability of systems like Netflix, Instagram, and Amazon. These companies use partitioning to ensure that their services can handle the massive data loads generated by millions or even billions of users, ensuring that their platform stay fast, reliable, and responsive. So in conclusion, whether you are working on your own backend system or developing solution for large scale companies, remember that the data partitioning isn't just a concept, but it's a powerful tool for building robust, efficient, and scalable systems. Thank you so much for staying with me till the end of today's video on why data partitioning matters. We covered a lot, starting with how it enables systems like Instagram and Amazon to basically scale seamlessly, diving into key methods like range-based and hash-based partitioning, and wrapping up with real-world example that bring this concept to life. If you found this video helpful, go ahead and give us a thumbs up. Your support really helps our channel grow and reach more learners like you. And if you are not already part of Prep 10 community, what are you waiting for? Hit the subscribe button and turn on notifications so that you never miss out on any of our feature content. Oh, and before you go, there is something special for you. Join our Prep 10 Telegram community as well. It is the perfect place to stay updated on latest job and internship opportunities, connect with like-minded peers, and grow together in your tech journey. The link you can find in the bio of this channel. We have got so much more lined up for you, especially if backend engineering is your thing. Stay tuned for more videos packed with insights, practical tips, and industry level knowledge. This is Sahib Kumar signing off. Until next time, keep learning, keep growing, and keep building. See you in some other video.